Hi guys, and welcome back to another flipped classroom lesson on YouTube. Today we're going to be jumping in a little bit into our chapter on quadratics. Earlier we've had a look at the null factor law and identifying what a quadratic equation is, and today we're going to be looking at solving quadratic equations using the null factor law and stuff that we've discussed already in class. Now in today's lesson it's going to be a little bit tricky because in year 9 we spent a couple of weeks going over how to solve and factorize various quadratic equations, and we spent about a lesson going through each one. We had the perfect square, we had some simple ones, we had some harder ones, and we spent quite a long time going over it, and I understand that it was quite tricky. Unfortunately, because we are delving a little bit more deeper into this topic, we are actually moving through each of these factorization methods in the one class. So bear with me, try and remember what we learnt last year, and if there are any problems at all, make sure you come and see me in class. Okay, so to start off with, we've got a list of 5 steps to go through in your head when solving any quadratic equation to hopefully get you to your final answer in the most efficient way. Now they are, first of all, make sure that your quadratic equation is on the right hand side of the equation and that on the other side it's 0. So you must have some sort of quadratic like we discussed yesterday and it's equal to 0. Next, before we start factorizing, we always have to check this one. Can we take out any common factors? And usually that's where people get stuck because they immediately try and go down to step 3 and try and factorize, when in reality they should have taken out a common factor first. Okay, so step number 3, we then factorize the left hand side and then solve using the null factor law, which is something that we've discussed on Thursday. Alright, let's just jump straight in and spend as much time as possible remembering how to factorize. Now in year 9, one of the first things that we showed you guys was that some quadratics can be very simple to solve, and what that meant was if you had 2 terms like in example 1a where the first one was an x squared and the second one was just a constant term without any x next to it, it would look similar to this equation, a squared minus b squared, because one of them would be a squared term like your x squared over here, but then the second one was also a square number. Now you can see that minus 4 can also be written as, well, if we write it out again, x squared minus 2 squared. It's a square number and that still equals 0. Now we said that in this scenario, if you can write your equation like this, we can easily factorize it to a plus b, a minus b, and I can already hear your groans. You can remember that it's always the first one plus the second one, and then it's the next bracket we just change it and put a minus sign in there. So for this question, if we were to factorize it, it would be x plus 2, x minus 2 equals 0. Now for this particular question, remember our fourth step was, after we've factorized it, to use the null factor law. Now remember yesterday we talked about that in each of these brackets these were labeled a and b, and for the null factor law to work either a must equal 0 or b must equal 0, or maybe even both of them were 0. And so to help us solve that equation we go either x plus 2 must be the one that equals 0, or maybe it's the x minus 2, that's the one that equals 0. Now if that's the case, that implies that either x is equal to minus 2 or x is equal to plus 2. Do you see how I did that? I moved the plus 2 over here to give us minus 2, and I moved the minus 2 across the other side to give us positive 2. So that means for this equation to work, to equal 0, either x must be minus 2 or x must be plus 2. Okay, let's go on to the next one. So here we go, x squared minus 25. What's the square number of 25? What number squared gives us an answer of 25? Well, it has to be 5 squared. So that means when this gets factorized, it's going to be x plus 5, x minus 5, and that still equals 0. Now, using the null factor law, that tells us that either x plus 5 equals 0 or x minus 5 equals 0. Now, that implies for this statement to be true that x itself must be minus 5 or x must be 5. So that tells us to make this statement true, for x squared minus 25 to equal 0, the value of x must either be minus 5 or plus 5, and that's what we're doing, trying to solve these equations to find out what the value of x is. And because it's a squared term, remember that game that we played in class? What number am I thinking of that can equal 25? Well, it could be minus 5 or plus 5. Same deal. Okay, example number 1c. 3x squared minus 12 equals 0. Okay, let's check our steps. First one, make sure that the right hand side of the equation is 0. Done. Next step, take out any common factors. Now, if we have a look at this equation here, 3 is not a square number and 12 is not a square number. So we can't use this formula up here, a squared minus b squared, because neither of those values are a square number. But if we follow step 2 and take out a common factor of, let's see, we've got 3 and 12, so a common factor of 3, what's left over? X squared minus 4. Now suddenly the equation that's left over, well, it's exactly the same as 1a, x squared minus 4. And both of these terms fit in with the rule we discussed at the start, meaning we can factorize what's left inside to, like in the first part, x plus 2 and x minus 2. Now we don't need to worry about the 3 because this isn't part of solving the equation. We're trying to find out what x is, not what this 3 is all about. Now we already know from 1a that from that question that x was equal to minus 2 or x is equal to 2. So it's the same solution to this part, and all it took to get there was to first take out a common factor out the front. So that's where some people get trapped. Okay, last one. Let's have a look at our steps. First step, make sure that the right hand side of the equation is equal to 0. That's definitely not the case. So we need to move stuff around so that we have 0 on the right hand side. Now there's two ways we could do it. We could move the 1 over here and flip our equation around, or we can move the minus 49 over here. I'm going to do the reverse. I'm going to put our 1 over here, so our equation becomes 49x squared minus 1 equals 0. So now we've got our equals 0, we can move on to our second step. Can we, wrong way, can we take out any common factors? No, there's no common factors between 49 and 1, so let's go straight to factorizing. Now the cool thing is, unlike C, where we had this coefficient, both of these numbers are in fact square numbers. 49 has the square number 7, and 1, well, its square number is just itself. So when it comes to solving this equation, we were used to so far just dealing with x. It had no number at the front, but because we have 49, we need to split it up so that it's 7x plus 1 and 7x minus 1. See how we've split the first term also up into its square numbers. It cannot disobey the rule. See how we've split it up into a and a? Just because here we didn't have any numbers in front doesn't mean that we just put 49x and 49x. It has to be split up into its square numbers as well. Now if you don't have a coefficient that it fits nicely like 49 and it's not a square number, then we go back to our 1c expression, and if it cannot, or if it's not a square number, we must first have to take out a common factor. Anyway, getting back to this one, we have to solve this now. This implies that either 7x plus 1 equals 0 or 7x minus 1 equals 0 using the null factor law. So solving this equation now, 7x equals minus 1 or 7x equals 1, which means x equals minus 1 on 7 or x equals 1 on 7. Now, be prepared for the fact that some of these quadratic equations won't give you whole numbers. With the first three, they were fine, they gave us nice full numbers, but for this one here, this gives us fractions. So the sign of a correct solution isn't always going to be a whole number. Sometimes you will get a fraction, and it's just having the confidence to know that you've done each of these steps properly so that your final answer has to be the one that is correct. Another way to check it out is to actually substitute this answer back into the equation. If you do 49 times a 7th squared, you should get the answer of 1, and that will tell you that you're on the right track as well. So that's our first example, and that's also, in each of these examples, we'll cover one different type of factorizing, and you'll have to learn each of them individually again if you've forgotten. So this is the first one, the difference of the two perfect squares. Example number 2. In brackets, you'll notice that this one is talking about taking out a common factor. In my opinion, a little bit easier than example 1. So to solve these, we're going to take out a common factor of both of these terms. And remember to do that, like we did in the last chapter that we did, we look at the numbers and we look at the letters. In this example here, we only have a common factor in our pronumerals, and that's the letter x. So we're going to take that out the front. So x is our common factor, and what's left over? X minus 7, and that's still equal to 0. Now, using the null factor law, we still have two terms. This one is our letter A, and this one is our letter B. So to solve it, this is telling us that either x equals 0 or x minus 7 equals 0, which implies x equals 7. And both of these numbers work. If x equals 0, well then the whole equation equals 0. But at the same time, if it equals 7, our equation also works. So we still get our two solutions, even though we don't have two lots of brackets to solve. This x still counts as our A in the null factor law. Okay, looking at this, we've got two coefficients, but once again, we can't get a common factor out of 3 and 5. So the only common factor is in the letters, or x. So to factorize, it would become x bracket 3x plus 5, and that equals 0. So to solve it, like in the previous one, either x equals 0, which is this guy here, or 3x plus 5 equals 0. Now let's solve this. 3x equals minus 5, and that means x equals minus 5 over 3. So see again, we ended up with a fraction, but if we're confident in the knowledge that we've factorized correctly, then this must be our correct answer anyway. Okay, and that's example 2, taking out a common factor. Example number 3 now. This is our simple cross method, and we'll go back to how we learned it in class last year. Now with these simpler quadratic equations, this is where the coefficient of our leading term at the front, the x squared term, is 1. If it was greater than 1, we had a different method, which we'll show in example number 4. But right now, for these two, when they have a coefficient of 1, we can follow this formula. Okay, so to solve this, what we had to do was look at our last term. And remember, what we did was we looked for factors of this number that when we multiplied them together gave us the second coefficient. So let's have a look at the factors of 3. Well, there's not many. You either have 1, and 3, or 3 and 1, the same one. Now notice when we add our two factors together, 3 and 1, it gives us the answer of 4. And once we've found our correct factor, that tells us how to factorize this equation. It comes out to be x plus 3 and x plus 1. And this is why they were the easier questions, because we could take our factors and immediately put them inside our brackets. Now we haven't finished yet because we need to solve it using the null factor law. So this tells us that either x plus 3 equals 0 or x plus 1 equals 0, meaning x is either minus 3 or x is minus 1. And that's our final solution. Okay, going down to the next one, looking at our final term here, we've got plus 3. Now from here we know that the only factors are 1 and 3, but look at our second term. The coefficient is minus 4. If we add these together, that gives us plus 4. What two factors could add together to give us minus 4? Well, don't forget that two negative numbers also give you a positive number. So when we multiply minus 1 with minus 3, that gives us still an answer of plus 3. Yet this time when we add them together, minus 3 plus minus 1 gives us an answer of minus 4. So that means our factorized form is x minus 1, x minus 3, and that equals 0. Okay, solving it now, it implies that x minus 1 equals 0 or x minus 3 equals 0. And solving these two means that x equals 1 or x equals 3. Alright, let's do some more of these easier ones to wrap your heads around it. C. Okay, again, starting at the end, we are looking for factors of minus 20. Okay, what two numbers multiply together to give us minus 20? Well, we have minus 4 and 5, 4 and minus 5. We have minus 10 and 2, and positive 10 and negative 2. Now let's stop here for a second and see if we've got the right answer. So when we add them together, it needs to be minus 1. So starting from the bottom, 10 plus minus 2 is minus 8. That doesn't work. Minus 10 plus 2 is minus 8. That doesn't work. 4 plus minus 5 is minus 1. Oh, there we go. We found the correct one. So that's wrong. Here's our solution. Factorizing it now, it's x plus 4, x minus 5 equals 0. And solving it, that gives us x plus 4 equals 0 or x minus 5 equals 0. Implying that x must be either minus 4 or x must be 5. Okay, D. Starting again at our last term. So we're looking for factors of minus 15, and they are 3 and minus 5, minus 3 and 5, 15 and minus 1, and minus 15 and 1. Okay, again starting from the bottom, we're looking for adding them together to give us minus 2. Minus 15 and 1 is minus 14. 15 and minus 1 is positive 14. Minus 3 and plus 5 is 2. So, wrong one again. And 3 and minus 5 is minus 2. So we found the right one. So we can factorize that to be x plus 3, x minus 5 equals 0, which implies x plus 3 equals 0 or x minus 5 equals 0. So solving this now, that means that x must be minus 3 or x is 5. All done. Now there's a couple more left in example 3, but I'll put them on a slide at the end to give you a bit of practice of factorising by yourself, and I'll give you the right answers in class tomorrow. Okay, example number 4. Now remember I said these were the harder types of factorising because they have a coefficient in front of the x squared, and it means that we cannot follow the same method that we did here, and we have to add an extra couple of steps. Now this can get tricky, so follow along. Now to start off with, we need to revise what the general form of a quadratic equation is. Remember, we can write it in as ax squared plus bx plus c equals 0, where a, b, and c are just numbers, any number, positive or negative. Now to start off with, instead of finding the factors of our last number like we did in example number 3, because it has a coefficient at the front, we actually need to add another step, which is multiplying a and c together. So the coefficient in front, that's a, and the last number, that's c. And in doing that for this example, we get the answer of 2. Once we've got this number, we look for the factors of this number. So no longer are we looking for factors of this last term, but now the factors of a times c. Now this is pretty straightforward because the only factors of 2 are 2 and 1. Now we're looking to find two factors that add together to give us plus 3, so we don't need any negative numbers. The only solution is 2 and 1. Unfortunately, we can't now go and, like in the previous example, put them straight into the brackets like this. We have to add yet another step to our method. Now that is to break down, we're going to separate this second term into its factors of 2 and 1. This is what I mean. We rewrite it as 2x squared plus 2x plus 1x plus 1 equals 0. Notice how the 3 has been separated into the 2x and the 1x. If I add them together, it just gives me the question. So I haven't changed it, I've just split it into the factors I found down here. Okay, now what we're going to do is split our equation in half. These two and these two. And we're going to take out the common factors between these two figures. Now looking at these two, the common factor has to be 2x. So I take that out the front and I'm left with x plus 1. And here, well, I can't really take out any common factors, so it's just going to stay as x plus 1. Now I've got two terms here now that I've taken out common factors, and these two terms have in fact another common factor. This time this term here has an x plus 1 and this term here has an x plus 1, so I'm going to take out another common factor of x plus 1 and I'm left over with the 2x and plus 1. And that's how we factorize these questions, by first splitting our second term into its factors, taking out one common factor, taking out another, and that will finally factorize our equation. From here we can solve. So using the null factor law, it implies that either x plus 1 equals 0 or 2x plus 1 equals 0. Now we need to solve these. That means x equals minus 1 or 2x equals minus 1, which means x equals minus 1 over 2. So that's completely solved it now. We've got x equals minus 1 and x equals minus half, and you'll notice when you substitute them back in, it solves the equation. because when you substitute in minus 1 it equals 0, and when you substitute in minus half it will also equal 0. Alright, let's try another one to make sure this method is solid in our head. Okay, first step, we need to multiply the values of A and C together. So that's 3 and minus 2. That gives us minus 6. This is the number that we look for factors of. And remember, the factors of this one, not this one, have to equal plus 5. Alright, factors of minus 6 are, well, 2 and minus 3, minus 2 and 3, 6 and minus 1, and minus 6 and 1. Alright, let's start off from the bottom. Minus 6 and 1 gives us minus 5. That's not right. 6 plus minus 1 is 5. So that's our one that we're looking for. These two won't work. Okay, so remember, we don't put it in the brackets now. We are splitting our second term into 3x squared plus, here we go, 6x and minus 1x. See, if I subtract the x, I get back to the original question. I haven't changed anything. But now, I can take out a common factor between each half of my equation. So, what's in common between these two terms? Well, it has to be 3x. So I'm going to take out 3x, and in brackets I'm going to leave x plus 2. Now looking at this, I've got minus x and minus 2. That's not going to help, because if you look, by the time I take out my common factors of this question, I'm left with two of the same thing inside the brackets. And with example 4b, if I left it, I'd have an x plus 2 and a minus x minus 2. That's not going to help. So what I'm going to do is take out a factor of minus 1 from both of these numbers to turn them into positive versions of themselves. So taking out minus 1, it's going to give me x plus 2. And suddenly I have my next common factor, which I can take out the front now, and it's left me with 3x minus 1, and that equals 0. Finally, I can solve this quadratic. This implies that x plus 2 equals 0, or 3x minus 1 equals 0. So that means x must be minus 2, or 3x equals 1, which is x equals a third, or 1 on 3. Alright, let's do one more. I'm going to skip to example 4D. This is the question which has the giant warning sign next to it, because this is a tricky one. Alright, let's do it. So, the first step, can you remember? The first step, we're looking for A times C, which is 6 times minus 10. That's minus 60. Okay, let's look at all the factors of minus 60. We have 1 and minus 60. Minus 1 and 60, I'll go through these pretty fast. 2 and minus 30. Minus 2 and 30. We have 3 and minus 20. Minus 3 and 20. 4 and minus 15. Minus 4 and 15. We have 5 and minus 12, minus 5 and 12, 6 and 10, minus 10, and minus 6 and 10, and that's it. Alright, now looking through these factors, we need to add them all together to try and find one that gives us an answer of minus 9. Alright, let's do it. These two aren't going to work because that's just going to give us 59 and minus 59. Same with these. This is minus 27 and positive 27. This is even worse. This is going to be minus 17 and plus 17. Okay, we're going to get close now. So 4 and minus 15, that's minus 11, no good. Minus 4 and 15, that's plus 11, no good. Alright, 5 and minus 12 is minus 7, no good. Minus 5 and 12, plus 7, still no good. Last two, 6 and minus 10 is minus 4, no good. Minus 6 and plus 10 gives us plus 4, no good. These are all the factors and none of them works. This means that this quadratic cannot be factorized. So there is a trick one in there. It cannot be factorized. Now that is not to say it cannot be solved. There is values for x, but they happen to be decimal places. So that means that we will look at other ways in the future to find out how to solve these types of quadratic equations using what we call the quadratic formula. But right now, if you were to try and solve it using factorization, you cannot do it. And so for this type of question, you cannot solve it using this method only. Alright, this brings us to our last slide. These are some extra practice questions that I skipped on doing in part of this talk. These are from number 3. These are from number 4. Have a go of them and see if you can get the correct answer. Make sure you follow the steps 1 to 5 that was on slide number 2. And let me know how you go and I'll give you the answers back in class. Remember, in year 9 we spent a couple of weeks going on each of these different types of factorization. We have the perfect square, taking out a common factor, the simple quadratics, and the harder quadratics with the coefficient at the front. Now, if you are struggling with any or all of them, or if you haven't learnt it in year 9, you need to be able to do this ASAP. So please come and see me, spend some time, come in at lunchtime, anything at all to make sure that you understand how to factorize. It's very, very important for this chapter, otherwise you're going to be sinking when it comes to this test. Alright, that's all I have to say. I hope you've enjoyed this particular video, and as always, I'm Mr. Rappell, and I'll see you guys later. Bye.